The four non-degenerate conics, namely circle, parabola, ellipse, and hyperbola, have been discussed in detail. In particular, standard equations of these conics were derived. The expansion of these equations gives rise to the general second-degree equations. In general, conic sections have equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, which is called the general second-degree equation, where a, b, and c are not all equal to 0. Most of the equations discussed thus far have equations with b equals 0. When b is equal to 0, the equation then becomes ax squared plus cy squared plus dx plus ey plus f equals 0. The graph of this equation is a circle, a parabola, an ellipse, a hyperbola, or in some special cases, a point, a line, a pair of lines, or no graph at all. If b is not equal to 0, the conic is rotated in such a way that its principal, major, or transverse axis is no longer parallel to one of the coordinate axes. In this section, we restrict our discussion to equations with b equals 0. The graph of a general second-degree equation can be determined easily if the equation is expressed in standard form. There is another way of determining the type of conic using the discriminant, provided that it has a graph and that the graph is not a degenerate conic. The discriminant is b squared minus 4ac. In this case, b is always equal to 0, since we restrict our discussion to equations without the xy term or when b is equal to 0. Since we assumed b is equal to 0, the discriminant is equivalent to negative 4ac. In particular, if the discriminant b squared minus 4ac is less than 0, the graph is either an ellipse or a circle. If a and c in the equation have the same sign, it is an ellipse. But if a and c are equal, the equation is a circle. If the discriminant b squared minus 4ac is equal to 0, the graph is a parabola. Either a or c in the equation of a parabola is 0. If a is 0, the equation is quadratic in y. But if c is 0, the equation is quadratic in x. On the other hand, if b squared minus 4ac is greater than 0, the graph of the general second-degree equation is a hyperbola, and a and c in the equation of hyperbola are opposite in sign. Take note, the value of a can be found on the x squared term, while c on the term with y squared, and b is always 0. Let us have some examples. Determine the type of conic each equation represents using the discriminant. Number 1. The equation is 9x squared plus 25y squared minus 54x minus 50y minus 119 equals 0. We need to compute for the value of the discriminant b squared minus 4ac. First, find the value of a, b, and c. Take note, the value of b is equal to 0 since walang xy term sa equation. A is 9 while c is 25. Substitute these values so we have 0 squared minus 4 times 9 times 25. 0 squared is 0 minus 4 times 9 is 36 times 25 is negative 900. Since the discriminant is negative and a and c in the equation have the same sign, the equation 9x squared plus 25y squared minus 54x minus 50y minus 119 equals 0 is an ellipse. Remember, if the discriminant is less than 0, negative 900 is less than 0, and a and c have the same sign, the equation is an ellipse. Another example. Use the discriminant to determine the type of conic of the equation x squared minus 4y squared plus 10x minus 16y plus 5 equals 0. Compute for the discriminant where a is equal to 1. Kung nasa ng may x squared term, dun mahahanap ang value ng a. Since we only have x squared, that means a is equal to 1. b is 0, and c is negative 4. Ang c ay mahahanap naman kung nasaan ang may y squared term. Replace these values and simplify. So we have 0 squared minus 4 times 1 times negative 4, and that is equal to 16. Negative 4 times 1 is negative 4, times negative 4 is positive 16. Since the discriminant is positive, and a and c in the equation are opposite in sign, the equation is hyperbola. If the discriminant is greater than 0, 16 is greater than 0, and AC are opposite in sign, the graph is hyperbola. Number 3. Determine the type of conic represented by the equation 4x squared minus 8x plus 6y plus 24 equals 0. First, find a, b, and c. A can be found on the x squared term. Thus, a is 4, while b is 0. On the other hand, c can be found on the term with y squared. But since the equation is only quadratic in x, c is 0. Wala tayong y squared term. So we have 0 squared minus 4 times 4 times 0. And this is equal to 0. Negative 4 times 4 is negative 16, and negative 16 times 0 is 0. Since the discriminant is equal to 0, the equation 4x squared minus 8x plus 6y plus 24 equals 0 is a parabola. Either a or c in the equation is 0. However, there are other cases with the same general form that are actually not a circle, a parabola, an ellipse, or a hyperbola. These are called the degenerate conics. The degenerate case of a circle is either a point or an empty set, which means no graph or does not exist. The same case applies for an ellipse. For parabola, the degenerate case could be a line, parallel lines, or simply the conic does not exist. While the degenerate case for hyperbola is an intersecting lines. Recall that the equation represents a circle if a and c are equal and a and c should not be equal to 0. Parabola if a or c is 0. Ellipse if a and c have the same signs. And hyperbola if a and c have opposite signs. What this means is that the equation may look like the graph of a circle, for example, but it's just actually a point or nothing, meaning the equation does not exist. Or the equation may represent a hyperbola, but when we solve for it, the conic are two intersecting lines, which is the degenerate case of hyperbola. The same for parabola and ellipse. The conic could be one of its degenerate cases. So to make sure if the equation represents a circle, a parabola, an ellipse, or hyperbola, or one of its degenerate cases, we compute first for its discriminant, given by b squared minus 4ac, then write the equation in standard form, using completing the square method. Let us have an example. Number 1. Use the discriminant to determine the type of conic given by 9x squared minus 16y squared plus 54x plus 64y minus 127 equals 0. Write the equation in standard form. First, use the discriminant test. A is 9, b is 0, and c is negative 16. Replace these values into the discriminant b squared minus 4ac. Simplify. 0 squared minus 4 times 9 times negative 16 is 576. Negative 4 times 9 is negative 36 times negative 16 is positive 576. Since the discriminant is positive, the graph, if it exists, is a hyperbola. To check, we need to express the given equation in standard form by completing the square. First, collect all x and y. Thus we have 9x squared plus 54x minus 16y squared plus 64y. Then transpose the constant term to the right-hand side of the equation. So this is equal to positive 127. Then we group all x and all y. However, since the operation here is subtraction, we need to be extra careful with the sign. Bear in mind that if we distribute this sign to this expression, the sign should not be altered. It should have the same sign with the given equation, negative 16y squared plus 64y. We distribute negative times 16y squared is negative 16y squared, which is correct. And negative times positive 64y will become negative 64y, which is not the same sign in the given equation. Thus, we change the sign here from positive to negative to make the equation right. This will now become positive 64y, which now have the same sign with the given equation. So we need to be extra careful with the sign if the operation is subtraction. Before we complete the square, we first need to factor out the numerical coefficient in x and y. Here, we factor out 9. So we have x squared plus 54x divided 9 is 6x. Minus, in here, we factor out 16. So we have y squared minus 4y. 64y divided 16 is 4y equals 127. We can now complete the square. First, in x. Square half the coefficient of x. In this case, the coefficient of x is 6. Half of 6 is 3. Square it, so we have plus 9. 3 squared is 9. Minus, next, complete the square for y. The coefficient of y is negative 4. Half of negative 4 is negative 2, and negative 2 squared is positive 4, equals 127. Do not forget to add these values on the right-hand side of the equation. Thus, we have plus 81 and minus 64. Take note, we factor out 9, so we must not forget to multiply it with this value. That is why we have positive 81. 9 times 9 is 81. Here, we factor out 16. So negative 16 times positive 4 is negative 64. Next, factor the left side of the equation. We copy 9 and factor the expression x squared plus 6x plus 9, which is x plus 3 quantity squared. Remember our technique? We take just half the coefficient of x or y. Here, the coefficient of x is positive 6, and half of positive 6 is positive 3. Minus, copy 16 and factor this expression, which is y minus 2 quantity squared. Half of negative 4 is negative 2, equals 144. 127 plus 81 is 208, minus 64 is 144. Divide the equation by 144 to make the right-hand side of the equation equal to 1. We have x plus 3 quantity squared over 16 minus y minus 2 quantity squared over 9 equals 1. 9 over 144 is 1 over 16, while 16 over 144 is 1 over 9. The resulting equation is of the form x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1, which is a hyperbola with vertex at negative 3, 2. Indeed, the equation 9x squared minus 16y squared plus 54x plus 64y minus 127 equals 0 is a hyperbola.